Hi friends, welcome to the Unit 3, Day 5 notes. We're going to jump into graphing rational functions. To graph rational functions, remember rational functions are when you have essentially a function, a polynomial divided by another polynomial. Remember, you can't divide by 0. So here we have this function f of x is equal to some polynomial p of x divided by q of x, and q of x in this case is not 0. This part is kind of key, that when we divide by a polynomial, remember we're dividing by something that has variables, we can't divide by 0. So what happens in these circumstances is that you're left with what's called an undefined part that would yield a 0 in the denominator. So these graphs are undefined if they give you a 0 in the denominator. So we either call these vertical asymptotes or we call them holes in the graph. Asymptote is where you see kind of this sudden shift, this like great increase or decrease on the graph. So it's like huge, like as it approaches that number, you see them go up or down, or just like a hole, a little part in the graph that's undefined. The parent function is 1 over x. That's the most simple rational function that we have, and the graph of 1 over x just looks like this. So we have essentially the points 1, 1 and -1, -1 are true, and then as you get fractional parts, so between 0 and 1, as you get fractional parts, what happens is this graph increases very quickly, and then it never actually touches the y-axis in this example. And then as you move out this way, it also decreases. Your x values get really close. Sorry, your y values, as your x values increase, your y values get really close to 0, but they never actually touch the x-axis either. So you have these things where it gets really close to, but doesn't touch. And that concept, that idea, is something that we hit very heavily on in calculus, and this is kind of the background that you need to be successful in that. So again, the idea is that you're getting really close, but never actually touching either the x or the y-axis in this example. P of x and q of x are defined as polynomials. Consider the rational function. So this is written in lowest terms. So remember, written in lowest terms, what does that mean? That means that we have reduced, simplified, all of those things, the fractions as much as possible. So if the absolute value of f of x approaches infinity, so what does that mean? That means as y approaches infinity, as your x value approaches some number a, well, then the x equals a is a vertical asymptote. Remember, x equals, those are vertical lines, vertical asymptote. So what I'm saying is, in this example up here, x equals 0 is this line right here, x equals 0. No, we can't have 0. You can't divide by 0. If you divide by 0, you're undefined. So what's happening here is that as these values go towards infinity. Remember, as I said, as the numbers between 0 and 1, as those fractions, as you get closer and closer to 1, this value increases a tremendous amount. Then that's what's happening here in this case. So we get x equals a. That's a vertical asymptote. If f of x approaches b as the absolute value of x approaches infinity. So what does that mean? Well, again, the same thing here. As you increase with your x values, as you're getting closer and closer, as you increase the number that you're using in your x, so you just keep on going farther and farther away from 0. If the values are getting closer and closer to this b number, in this case, this b is 0, we're getting closer and closer to 0, but we never actually get to 0. Think about this. I could put in a really large number for x. I could put 1 billion, 1 million, 1 trillion, 1 zillion. Keep going forever and ever and ever. I'm not going to get 0 because that 1 is always going to be a number. 1 divided by anything is going to be a value. So then we get this, the line y equals b as a horizontal asymptote. So here we've talked about two things now. We've talked about horizontal asymptotes, we've talked about vertical asymptotes. Vertical asymptotes are huge in terms of, you know, kind of the shape in the graph. We need to note what's happening. The horizontal asymptotes are good to know because we're never going to touch that value. You're never going to get 0 in this case. So this is kind of like, you know, just surface level. Next video, we're going to dive in deeper into the vertical asymptotes and really talk about what's the difference between a hole and then also between a vertical asymptote like the example that we gave here. Have a good day.